So in our experience, the optimal scenario for continuous value delivery is an enterprise-wide deployment of the scaled agile framework, and the use of a common cadence that synchronizes all programs and teams is a key mechanism that enables this to occur. Well, however, it must be recognized that it's often difficult for organizations to go all in with Agile for various reasons, such as dependencies or external partners, organizations who are using waterfall, internal culture that requires time to shift to Agile mindset, etc. As proposed by SAFe, teams can run with Scrum or Kanban as an Agile method. Additionally, it is possible to coexist with other lifecycles. Team and other programs can choose their lifecycle depending on their needs and their Agile readiness. And this solution has the advantage to let some teams smoothly adopt Agile, while other teams could choose to other lifecycles to work with, such as, for example, the V model, disciplined Agile delivery, iterative, or waterfall. This is something that we did at major Swiss financial institutes as well. We had waterfall, iterative, agile, and maintenance lifecycle all together defined. There are companies around with huge process assets and existing quality management systems. There are even companies which we have seen with more than 6,500 standard operating procedures in place and several thousand people working on different solutions. So it is common that in larger companies, a lot of practices, standard operating procedures exist. And it's also common that different lifecycle models are currently executed in the same company. And for that, we need an agile quality management system, which needs strategies, concepts, and guidelines on how such an integration and extension can be done. There's also one practice described in SAFe, which is called Technical Strategies for Agile and Waterfall Interoperability at Scale. Now I would like to go into some of the aspects, and first I would like to talk is about the organizational aspect of doing so. And we see here quality management systems, and organizations, they must demonstrate that their system meets its intended purpose and has no unintended consequences that might cause harm. That is what I said with the FDA requirements. And they must also develop the objective evidence required to prove that the system conforms to regulatory standards. And to that end, organizations that build high assurance systems, they define their approved practices, policies, and procedures in the quality management system. Unfortunately, quality management systems of many organizations are still heavily influenced by traditional phase-gated waterfall methods, and this seriously inhibits or can even prevent the adoption of newer methods. As an example would be that, as we have seen in the rational unified process, the use of use cases was almost a given and is totally interwoven with the process. So this picture here from SAFe, this comes from SAFe, states that also the quality management systems need to be agile as well, and in our case, need to take different life cycles into consideration. So you can expect that the quality management system itself will undergo much more changes than in the past. Fortunately, most lifecycle models describe more the organizational aspect of work. So they say how to plan, how to improve, how to build, how to document, but not as much about how something is done, about the engineering practice. So you need to show how to synchronize milestones and different cadences of deliveries. And a lot of companies have even milestones with numbers. And just imagine, I just seen that yesterday in Germany, what means milestone number 7? If you're new to a company, that's totally not possible what you say. So you need some design patterns like interfaces to use. You need also to be able to answer what happens with the existing documentation. If you have an application that exists since 20 years, you will find a lot of content there. So what kind of documentation is expected in regards of the solution which you want to build, change, or maintain. And regardless of the chosen lifecycle model and the sequence of activities, it is important to ensure that inputs and outputs maintain a consistent state. For example, in the FDA terms, this is called the design control. And in our view, regulatory perspectives align well on the value and the importance of design inputs as the basis for the design of systems, and both align on the value and the importance of the design output that defines the result of the design process in a way that allows the design to be validated. And finally, both align on the value of verification and validation, showing that requirements and ultimately the user's expectations have been satisfied. So what can be different within different life cycles? What will be the same? At the end, the documentation might be produced differently using agile principles and practices, but the finished product might not look any different than it did before agile was introduced. So there is a solution-centric approach. So what are the accepted practices to use? We need to start decoupling of release elements. With that, I would like to show that you have also processes instances, and here this is a description, a part of a meta model, and we see that we have process instances which reflect the process description of a specific lifecycle, and they even can have different meta models. So in some you have milestones, in other lifecycles you probably don't have, and these are all bound to the process elements which we are using. And the process elements of activities of the process, they're organizational depending, and the practices of engineering, they're depending on the how you build something, how you do something. We see here an example which is heavily used, which is a very popular model used, for example, in the automotive industry. It's called the V model. It has a lot of practices are defined on how things get documented, designed, implemented, and tested. Most already existing practices can still be used, but you have to differentiate between the engineering practices and organizational patterns. An example for engineering could be how to define test data, test cases, how to validate something. And for organizational requirements, it could be, for example, how to evolve, review, release, and document a design. If you talk about documentation, there is, we see here a symbolic view of a solution-centric approach as a skeleton to build up a solution which comes with the natural evolution, seen as an analogy in architecture. We see here that we have a skeleton, probably this could be a use case model, and each time we come up with a system increment, we fill up those blankets here, and then we have some kind of a use case or alternative flows which grow into the use case model. We talked about this solution-centric approach in detail in our previous webinar about agile requirements engineering. As said, in SAFe and in Agile, a complete upfront documentation of requirements is neither practical nor enforceable. So here's a possible solution that works regardless of the used life cycles. We start with a useful patchwork documentation. This is based on a skeleton, which can be completed step by step, following the natural evolution of the solution. With each increment, we work here. For example, we start with a vision and some features, then we fill it up and well. If you want to do that somehow, you need the guidelines to build up such an evolutionary and incremental documentation. There has been one company in Holland, for example. They agreed on such a solution-centric approach, and what they're doing is they never fill out the acceptance criteria, for example. They just point to they just trace to the right point into the skeleton documentation. And for that, if you have that, the skeleton must hold all attributes to scale up, support the needed flexibility, and support for iteration, but must not contain all content in advance. And we have seen that an agile approach is best to comply with here. We see here an element of the SAFe, which is called the solution intent. We could consider that also as a container for such a skeleton as we have shown before. And when building systems that have an unacceptable high cost of failure, one significant barrier to agile adoption is the need for more rigorous definition and validation of system behavior. While many practitioners resonate with the Agile Manifesto value statement of working software over comprehensive documentation, those can become conflicting priorities for enterprise that really need both. So engineering of complex and highly reliable solutions requires and creates large amounts of technical information. Much of this information reflects the intended behavior of the solution, features, capabilities, stories, non-functional requirements, design, architecture, models, for example, electrical and mechanical interfaces, customer specification, and traceability, which build up the solution. And easy speaking, it contains what the current system does now and what changes are intended for a future state. Now, if we remind that we need to have a quality management system which clearly defines what is needed, then you need to be defined very clearly what that looks like. It's not okay to have several teams, projects, or however you call your endeavors to talk about the same things in different meanings, terms, or harmony. We see here an example in Applied SAFe where we show the work products and its relations. We see here that the solution is made up of the current solution and the future solution, and the future solution is imposed by the solution intent, which sets the person for the solution vision. And each time that we develop something from the future solution to the current solution, this is done with a solution increment, which is under control with the solution increment definition of done. We see also that the solution consists of several systems, and we have here the composite pattern that systems can exist, can contain other systems as well. And we really think that a model like this helps a lot to cut down on discussion time on how something is meant and to support it with the ALM tools, because if you have such clear work products and cardinalities, we really can implement it with a tool. Now I would like to talk about architectural aspects and applying different release frequencies raise another question. Is a release a monolithic all or nothing process? And if so, the release strategy would be limited. Fortunately, that is usually not the case. In fact, even simple solutions will have multiple release elements, each operating with different release strategy. Think of, for example, of an app for a flight booking system. No, for a flight booking system. The app can have an agile lifecycle. Here on the top, it is possible to build the booking system on a Streamlit 4 on a mainframe, and this is maintained in a waterfall lifecycle. We don't recommend this, but this is possible. And in SAFe, such separate flows of values are called streamlets. They represent a full end-to-end flow of value, and each streamlet can and should be managed to deliver value according to its own needs and pace. And identifying those streamlets is critical to enable release on demand, and as they allow the different elements of the solution to be released independently in a separate cadence. A lot of implementations are also working with feature toggles. Probably you have heard about it, but feature toggles are like switches which enable deployment of features into production without making them visible to the end user. They help to avoid the need for multiple code branches and allow developers to deploy new features to production, but only activate them when the enterprise is ready to consume them. And after the feature has been released and deemed stable, the toggles are removed to avoid any technical debt. As stated in the sample from the slide before, that's how it can be done as defined in the QMS. And you can steer that with, here is an example, with the so-called release definition of done. And in Agile, this is like a contract, but in Waterfall, it might be written within the process description of itself. So that means you wouldn't change the the release process in the waterfall lifecycle, but you would make it in the release definition of done lifecycle, and in the agile lifecycle, you define the release definition of done, and then you can have the same behavior, but it's not the same way. So now I would like to talk about some engineering aspects, and the ability to release on demand is a critical aspect of SAFe, which raises 3 questions that allow programs to embrace the SAFe principle, assume variability, and preserve options. The questions are, when should we release, what elements of the system should be released, and which end user should receive the release. And having all the 3 options accelerate and provides flexibility in delivering value. And further, release on demand closes the loop on evaluating the benefit hypothesis. Releasing provides data needed to decide whether further exploration of an idea is warranted. In the example of a flight booking system, that you need new functionality, or perhaps a different approach on the mobile devices is needed because it was into the wrong direction. And for that, you can have several release strategies that may apply. You can release on PI cadence, release less frequently, release more frequently, but at the end, or release on demand. And for organization, building complex solutions with system of systems, as we've seen before, fixed or less frequent releasing is probably oversimplistic. Big systems often contain different types of components and subsystems, and each of which may leverage its release model. In that case, the most general model is release whatever you want and whenever it makes sense to you, within an appropriate governance and business model, of course. Release on demand requires the quality management system to develop the following capabilities. You need to be able to decouple the release from development cadence, decouple the release elements from the solution, and architect the solution to support incremental releases. And the following slide will describe such capabilities. To integrate frequently, we work with mockups and design to interfaces. Those mockups allow to test interface assumptions before the system is really available, and nothing helps as much as a physical integration. And when, as we see in this example, the waterfall team will only deliver working software in the end, and then interface become the most real thing possible. Mockups are good when they bridge both the system integration and personal communication gaps between the teams. Mocks simulate interfaces and should be discussed first during architecture and design workshops. The best case scenario occurs when the waterfall teams themselves create mockups for agile teams. If this is not possible, the agile teams could do it by themselves, but they need to be carefully reviewed by the waterfall counterparts. Otherwise, they will only test a set of invalid assumptions. So you start to design to interface when you're using mocks, and it is highly recommended to couple mockup development with the native means of capturing the interface that a program language provides, for example, like interfaces in Java and so on. This will allow developers to simply replace each mockup with real implementations as soon as it is available. And if inconsistencies are found, capture them immediately. Frequent integration tests the code and the assumptions that went into it. And as we show here in the picture, by frequent, we mean far more frequent than once near the end of the project. So mockups back for implementation of the logic associated with the mockup interface, which is on its own fastest integrations. So integration can be full or partial, but in either case, what's important is that team integrate without fear. If there are integration failures, team fix the integration errors first, and then go back to their own agenda. While realistically, this is nothing like automated continuous integration as proposed by SAFe, but at this level, it still has immense value, even though it's on-demand, manual, and not automated. Good system architects, they use design patterns in their systems. Patterns are important because of the inherent complexity associated with software development and our inability to predict for the long term. And this is true for requirements as well as for system design. Certain system behaviors will change for sure over the time of the implementation. And patterns, they provide design approaches that are more immune to change and lend themselves better to a refactoring. Older engineers will recognize such patterns as they have been named in the book Design Patterns, written by Eric Gamma and Associates. Design patterns such as bridge, adapter, decorator, and chain of responsibility are also helpful here. They foster separation of concerns. Factories foster use of mockups, testability, and early integration as the instantiation of the entities can be separated from their use. Facade patterns foster early validation of integration with legacy systems and so forth. So consider patterns not so much as building blocks for your system, but rather as ways to isolate variability, which will likely be higher if it is dependent on later breaking developments from the waterfall teams. I now would like to summarize our lessons learned from several customers. And what we have seen, that mixing of agile and different life cycles is possible. For that, you need to architecture processes for multi-life cycles. You need to separate between organizational aspects and solution aspects. And because the solution aspects, they tend to be equal for all life cycles. Use design patterns to build independent deployable systems and use architectural features such as feature toggles and switches and so on. It is key to separate what shall be done from how something is done. What shall be done is usually modeled as an activity in a process model. The how something is done is usually modeled as a practice or a standing operating procedure, and this is not the same. So don't interwove such activities and practices to hard code how something is done. Build and rely on heuristics to model the process for its usage and ensure that the practices can be changed or selected easily by the users themselves. So let them decide if they need a facade pattern or an adapter pattern. The quality management itself needs to be easy, accessible, and easy to use. It needs also to allow fast process changes and pilot in appropriate levels. We have seen that more than 3 months in Cadence on releasing new processes is not good. We can't have a system which only improves its processes once a year. This is just too slow for the users. So you need to promote transparency for each endeavor. Process instantiations need to be specialized in order to reduce waste. So if you have 10 programs launched, you usually would have 10 different variations of the very same organizational process, but each of them has its specific version or specific capabilities of the process. You need to train engineers in emergent design, refactoring techniques, and design patterns, and then it works as well. What I would like to say then, this is the but, which I would like to come up, is it's a very complex thing, and it's and you cannot underestimate the complexity of mixing life cycles, even if they're only agile life cycles. So you should avoid, if even possible, to mix life cycles at all. I heard that a lot of times now that people start off creating their own life cycle, which they call best of a breed, and I really cannot push as much emphasis on that it's really underestimated how complex this could be and how those things work together. I really have a great respect for people coming up with models of life cycle models with process, because it is much more complex as you could think of in the first one. Don't fool yourself if you're a manager. You can't mix waterfall with agile to achieve higher outcomes, higher customer value in a shorter time, and keep in the same time the project's fixed time, fixed budget, and fixed functionality. This is a silver bullet which will not work. And I just heard that 1 month ago at the conference, and this is really something that worried me. And change value-driven life cycles like Agile into a really risk-based approach waterfall in order to avoid design variability. This is something that you shouldn't do because nobody in these days in this UCO world can say what will be changed in the future and how things would look like.